A 50 ohm resistor is in parallel with a 100 ohm resistor. Current in 50 ohm is 7.2 ampere. What is the value of a third resistance to be added in parallel to this circuit to make the total current 12.1 ampere? So let us draw the circuit. The circuit is not given. So let us draw the circuit first. A 50 ohm resistor is in parallel with a 100 ohm resistor. Okay. So there is a 50 ohm resistor which is in parallel with a 100 ohm resistor. Current in 50 ohm is given as 7.2 ampere. Current flowing through this 50 ohm resistor is 7.2 ampere. What is the value of a third resistance to be added in parallel to this circuit? So suppose a third resistance also is added in parallel to this circuit. So what is the value of that resistance? We have to calculate it. So let us mark it as R. So what is the condition? To make the total current 12.1 ampere. So we have to make the total current 12.1 ampere. Okay. So there will be a voltage source V, and in order to make the total current 12.1 ampere, what should be the value of that resistor which is to be added in parallel to the parallel combination of these two resistors? Okay. So there is a 50 ohm resistor connected in parallel with 100 ohm. Current flowing through the 50 ohm resistor is 7.2 ampere. And in order to make the total current of this circuit 12.1 ampere, what resistor has to be added in series with, has to be added in parallel with this parallel combination? So that is the question. Okay, so let us solve. So what we have is a 50 ohm resistor and current through that resistor. So using this, we can calculate the voltage across this 50 ohm resistor. Okay, so voltage across 50 ohm. So according to Ohm's law, voltage across a resistor will be equal to I into R. That is current flowing through that resistor into its resistance. So that means 7.2 into 50, which is equal to 360 volt. So we will get it as 360 volt. So we know the voltage across this 50 ohm resistor, and this 50 ohm is in parallel with this 100 ohm as well as with this unknown resistance R. So the same voltage 360 will appear across this 100 ohm and this unknown resistance R. So we know the voltage across this 100 ohm resistor. So we can calculate current through the 100 ohm resistor. Current through 100 ohm resistor is equal to, so according to Ohm's law, current I is equal to V by R. Voltage across 100 ohm divided by the resistance. So voltage is the 360 volt divided by resistance is 100. So the answer will be 3.6 ampere. So now, so we cannot calculate the current through this resistor, because if we have to calculate the current, we should know the value of resistance. Current is calculated as V by R, but resistance is unknown, current is also unknown. But here we have the total current flowing through this circuit. Okay. So we have got current through 100 ohm as 3.6 ampere. Let us mark it here, 3.6 ampere. And we don't know this current I. So as it is current through unknown resistor R, let us mark it as I suffix R. So we know the total current is the sum of current flowing through these three resistors. So we can write the total current 12.1 as the sum of 7.2 plus 3.6 plus this current IR. So from this we can calculate IR. So the current IR is equal to total current 12.1 minus these two currents 7.2 plus 3.6. So we will get the current through this resistor as 1.3 ampere. Okay, this is current through the unknown resistor will be 1.3 ampere. So we already know the voltage across this unknown resistance, that is 360. And now we have calculated the current through the unknown resistor. So now we can simply calculate this resistance R. So according to Ohm's law, resistance R will be equal to voltage across it divided by current flowing through it, V by I, which is equal to 360 divided by IR is 1.3, and the answer will be 276.92 ohms. Okay, so when we add a resistance of 276.92 ohm across the parallel combination of this 50 ohm and this 100 ohm resistors, the total current will become 12.1 ampere. So the answer is 276.92 ohm.